All right, so now we're going to be talking about how to prove triangles similar. Similar figures, remember we use that little squiggly to represent similarity. These are figures that have the same shape but not the same size. For example, if I have an isosceles triangle and I dilate it, it's still going to be an isosceles triangle. It's just going to be either a bigger or a smaller isosceles triangle. Now, when we are talking about similarity, what that means is corresponding angles are congruent and their corresponding sides are proportional. Whereas if we're talking about congruent figures, the corresponding angles and corresponding sides are congruent. So let's talk about what it means to be proportional. So let's say that I had an isosceles triangle with the dimensions, let's say 4, 4, 10. And I dilated that, and my scale factor was 1/2. I'm going to still wind up with an isosceles triangle. But what it means to have a scale factor of 1/2 is that means that all my sides on my original triangle were multiplied by 1/2, so I wind up with a 2, 2, 5 as my 3 side lengths. And let me call this triangle ABC and this triangle A prime, B prime, C prime. So what it means for side lengths to be proportional is that if I took side length AB over side length A prime, B prime, that ratio would be equal to side length BC over side length B prime, C prime. And that ratio would be equal to side length AC over side length A prime, C prime. That's what it means for the side lengths to be proportional, is all the ratios of your corresponding side lengths are equal. Because again, if I did AB over A prime, B prime, that would be 4 divided by 2, which is a 2. If I did BC divided by B prime, C prime, 4 divided by 2 is also a 2. And if I did AC divided by A prime, C prime, 10 divided by 5 is also a 2. So that's what it means for side lengths to be proportional. And then also similar triangles have congruent angles. So angle A would be congruent to angle A prime. Angle B would be congruent to angle B prime. Angle C would be congruent to angle C prime, since this is an isosceles triangle. AC and A prime, C prime are all congruent. All right, so what I just did up above, that's called a similarity ratio. It is the ratio of the corresponding sides of two similar polygons. Typically it's written with numbers, so my ratio would be 4/2 or 2/1 when we reduce, and we should always reduce the similarity ratio. So let's look at this next example. These are similar triangles. The similarity ratio of triangle ABC to triangle DEF. So that means side AB corresponds with side DE, since they're in the same position in my two triangles here. So going from my bigger triangle to my smaller triangle, it would be a 20/5. However, 20/15. However, we do need to reduce. So both 20 and 15 are divisible by 5. A 20 divided by a 5 is a 4, and a 15 divided by a 5 is a 3. So my similarity ratio from triangle ABC to triangle DEF is 4:3. Now going backwards, let's say I wanted the similarity ratio of triangle DEF to triangle ABC. Then I would do 15 divided by 20, which is just the reciprocal of that 4/3, and that's a 3/4. All right, so you will be asked to write the similarity ratio, and this is how you do it, or what I mean to do it. In level 4, we will be proving triangles similar to one another. These are the 3 ways that you can prove triangles similar. AA similarity means that if you have two triangles with two pairs of corresponding angles congruent, then you can state that they're similar right away. You do not need a third pair of angles because remember by the third angles theorem, the third pair of angles are just automatically going to be congruent. So it's unnecessary to have a third pair of angles. So you just need two pairs of angles to prove that they are congruent. Sss Similarity states that if you have three pairs of corresponding sides proportional, then you can automatically say that the two triangles are similar. So originally up here, I didn't show you that the angles were congruent. I just showed you that I had three pairs of corresponding sides proportional. And so I could have automatically, without even knowing the angles were congruent, I could have automatically said that these triangles were similar. And then SAS, that states that two triangles are similar if we have two pairs of corresponding sides proportional and one pair of corresponding angles congruent, and it needs to be the corresponding angles in between the two sides. Okay, so some of you might be thinking, well, we had AAS congruency and ASA congruency theorems. Why do we not have that for similarity? Well, if you can see, if I had two pairs of corresponding angles congruent and one pair of sides proportional, well, I already have two pairs of angles congruent, which satisfies the AA similarity theorem. So that one pair of sides proportional is completely unnecessary. Same with ASA. I already have two pairs of angles congruent, so I can automatically just use AA similarity to say that the triangles are similar to one another. S is unnecessary. All right, so in this level, we're just going to identify if triangles are similar by showing our work, looking at angle measures and all of that, and side lengths being proportional. So here, by the triangle sum theorem, if I do 180 minus this 44.42 minus this 57.1, I wind up with this top angle on the smaller triangle being a 78.46 degrees. And using the triangle sum theorem on my larger triangle, I wind up with this top angle being 44.42 degrees. So it says, are the two triangles similar? We are going to write yes. It does say to explain, they are similar by AA similarity. Because I have three pairs of corresponding angles congruent. However, I only need two pairs of corresponding angles congruent to say that they're similar. So let's make sure that we're using AA similarity and not AAA similarity. I'm also going to explain some more. Using the triangle sum theorem, we were able to prove at least two pairs of corresponding angles congruent. All right, so that answers the first part of the question. The second part of the question states, if the triangles are similar, we're going to identify any missing angles, which we already did, so we're good on that front. But then it also says identify any other side length measures. So let's actually label these angles. The 44.42 degree angles are congruent. It's important to identify which set of angles are congruent. I'll explain why in a moment. The 57.12 degree angles are congruent, and the 78.46 degree angles are congruent. Now, we are going to find our missing side lengths. So I'm going to label this missing side length X. Let's try to find that now. Well, I have the side that's in between the one congruent tick mark or arc and the two congruent arcs. On my larger triangle, the side between the 1 and the 2 congruent arcs, I'm going to label that y, a different variable. Okay, so those two that I circled in pink correspond with one another. The side that's in between the 1 arc and 3 arc angle is the 6 on my smaller triangle. The side that is in between the 1 and the 3 arc angle is the 8 on my larger triangle. So those two correspond with one another. So then by process of elimination, this unknown side and this side of 6 correspond with one another. So we're going to use the two yellow sides to show that these triangles are similar, or to find the similarity ratio. So I'm going to do 6 over 8. And let's find x first. I'm going to set up a proportion to help me find x. The 6 comes from the small triangle and the x comes from the small triangle, so those need to be in the same position in your similarity proportion here. And so that x corresponded with my 6 on my large triangle. This is one way that you can write your ratio. You could have also flipped this around and flipped this around and had an 8 over a 6 is equal to a 6 over an x. You could have also chosen two sides from the same triangle, so a 6 over an x over an 8 over a 6. There's so many ways that you can set up the similarity proportion. It does not need to be completely identical to what I have, but it does need to make sense. The sides need to be corresponding to one another. So now, cross multiplying, I have a 36 is equal to an 8x, and then dividing by 8 on both sides, x comes out to be a 4.5. So now I'm going to use that 6 over 8 ratio again to help me find y. If I use the 6 over the 8, then I need to do 7 over y. And now I'm going to cross multiply here. So I wind up with a 6y is equal to a 56. Dividing by 6 on both sides, I wind up with y is equal to 9 1/3. I don't want you to round. I'd rather you use fractions than round your decimal here. Okay, so we got 2 more to go. For this next one, are the triangles similar? We need to identify if the similarity ratios are equal because we don't have any pairs of corresponding angles congruent. So it looks like AB and EF correspond with one another. So if I do a 0.68 or a 1 over 0.68, does that equal? Now I need to identify the next pair of corresponding side lengths. So it would be the 5.83 and the 2.13. And does that equal the last pair of corresponding side lengths, which would be 6.4 over a 2.42. So if I use division here, a 1 divided by a 0.68 is about a 1.47, and a 5.83 divided by a 2.13 is about a 2.74, and a 6.4 divided by a 2.42 is about a 2.64. Since these ratios are not equal, that means that the similarity or the sides are not proportional, so these two triangles are not similar. All right, I'm going to have you pause the video and try the next one completely on your own. We cannot use that side splitting theorem because we don't know these sides are parallel. Notice the directions are different, so I'm going to have you read through my response, and this is exactly what I'm looking for in these types of problems.